Hello and welcome to yet another riveting section about pre-calculus, and this is the fourth unit that we are doing this year, and we are talking about complex numbers. And complex numbers is kind of a very interesting concept. They are widely used in computing and software and stuff like that, but your practical everyday life type thing, you're not really going to run into them, but it is a very powerful thing that we can do. So what we want to do is we want to be able to represent square roots of negative numbers as multiples of I, represent complex numbers in the form of a plus bi or in the complex plane. We want to simplify powers of I using their cyclic nature and determine the absolute value of a complex number. So we've been talking about real numbers, and these are real numbers or numbers on a number line. But then we have this concept of imaginary numbers. So let's kind of take a look at something here for a second. If I were to take this equation and solve this for x, okay, and this means that some number x times itself, x squared, is equal to negative 1. Now, if I were to take the square root of both sides, then I would do something like this, and I would get that x is equal to the square root of negative 1. Now, there's a problem with this, is that this cannot be done. Okay, this has no solution, okay? And so, the reality of it is that we can't take the square root of a negative number. So we can't take the square root of a negative, all right? Now, the reality of it is you have to say, okay, you have to ask yourself the question, what number multiplied by itself gives you negative 1? So what number multiplied by itself gives you negative 1? Okay, is the question. And so, if you were to take, let's just say 1 times 1, that gives you 1. Okay, if you take negative 1 times negative 1, that gives you 1. So anytime that you square a number, okay, you get a positive number. So when you have this equation where you have x squared equal to a negative number, you can't evaluate it. Until now. Okay, so that's in the set of real numbers. Okay, there are no real numbers that will answer this question, so we have to come up with a new system called imaginary numbers. Now, I know what you're thinking. What the crap? Okay, someone just physically just came up with this number system, and they're imaginary. Okay, and so the reality of it is that when we do this, if we take x squared, if we take the square root of x squared, okay, take the square root of both sides, and you get that x is equal to the square root of negative 1. We've created this thing where we said, okay, well, let's let the square root of negative 1 equal the number I. Okay, and this is very, very powerful, okay, because this allows us to take the square root of a negative number, okay, of a negative number. And the reason why we did that is because we had, when you are dealing with, computer software and computing, you run into this issue where you will end up taking the square root of a negative number, okay? And so what we've done is we have created a number system. So we've created a number system that allows us to take the square root of a negative number, okay? And so what it really boils down to, guys, is this is used widely in electronics, so that computers can compute these numbers. Otherwise, computers would just crash and they wouldn't work, okay? So if you're sitting there and you're like, this is the dumbest thing that I have ever heard of, this is so stupid that we have come up with a set of imaginary numbers, well, you know what? without these imaginary numbers, you wouldn't have your cell phone, you wouldn't have Snapchat, you wouldn't have the Instagrams. So you can thank the people that came up with this number system so you can Snapchat your friends the duck face, which I think is absolutely ridiculous. Okay, I digress. Okay, but then you have, okay, so then you have this imaginary number. Okay, so let's talk about imaginary number. Whereas in the form of bi, where b is a real number and I is the square root of -1. So let's kind of take a look at, see how we get that. And so when you take something like this, let's say you're taking the square root of -36. What you can do is you can split up the square root of -36 into the square root of 36 times the square root of -1. Now when you take the square root of 36, that gives you 6. And then when you take the square root of -1, that gives you I. Therefore, you have the number 6I. Okay, so we can actually do this now, which is actually pretty cool. Okay, so let's do the same thing for the square root of -81. You know, if I were to evaluate this, I would rewrite this as the square root of 81 times the square root of -1. Okay, I can evaluate the square root of 81, and that gives me 9. And the square root of -1 gives me I. Okay, so it's really not too bad. Okay, the big thing is this step here, going from here to then here. All right, and understanding that the square root of -1 is equal to I. All right, so now let's take a look. Let's simplify the square root of -50. Okay, so this would be something where you'd go, all right, well, if I were to evaluate this, I would rewrite this first as the square root of 50 times the square root of -1. Okay, to just get rid of that negative business. All right. Now, square root of 50 is not a perfect square, okay, so we can't really evaluate that. However, what we can do is we can split this up and say that this is the square root of 25 times the square root of 2, okay, split up 50 and find a perfect square that fits into 50, and then multiply that by the square root of -1, okay. Now, I can evaluate the square root of 25, and that's just going to give me 5. The square root of 2 I can't evaluate, so we just leave it as the square root of 2. And then the square root of -1 is just going to give us I. So I've got 5 square root of 2 times I, okay? And what we can do, because we can reorder, when we multiply things, we can reorder them, all right? The standard way we want to write it would be 5 times I times the square root of 2, and that would be the number, okay? And that's that answer right here, okay? So let's take a look at, something else. So here's what we know, all right? We know we want to simplify some powers of I. So if I is equal to the square root of -1, then if I were to square I, okay, take that number and then square it, then that means that I'm also squaring the square root of -1, okay? So then if we were to square I, and if I take the square root, or square the square root of -1, when you square a square root, that gets rid of the square root, and you're simply just left with the number -1, okay? So if you take I squared, then you multiply that by -1, okay? So then, we can use some of these ideas and kind of expand on that. Let's say, okay, well, what about if we had I cubed? Okay, well, that's just going to be I squared times I, all right? I can split up I cubed into the product of 2 other numbers. Now, I know what I squared is. I squared is -1. We just found that out. So this is -1, and then we're going to multiply that by the square root of -1, okay? Now, what we already know about this is that we know that the square root of -1 is the number I. So I can come in here and I can say, well, this is really just -1 times I, all right? And -1 times I just gives me -I, okay? So what we have is all right, we've got that I is equal to just the square root of -1, okay? We've got I squared is equal to -1, and then we've got I cubed, which is equal to -I, okay? So what about I to the 4th, okay? Well, I could split that up into I squared times I squared, all right? And I know that I squared is -1, so this is really just going to give me -1 times -1, and -1 times -1 is just going to give me 1. So I know that I to the 4th is equal to just 1. All right, so now let's think about something, all right? What if you just had, say, I to the fifth, okay? Then what we end up happening is we get this. We get I to the fourth times I, okay? And so then what we then want to say is going, okay, well, what if we had this? What if we had just I to the fourth? We know that I to the fourth is equal to 1. All right, so this is going to be equal to 1 times then I. So I to the fifth can be simplified to just back down to I. All right, and the process repeats itself, and that's what's happening down here. You've got all these different values for I squared, I cubed, and so on, all the way down to I to the eighth. And what happens is these numbers, they change, and they go, okay, well, what if I is just I, all right? I squared is -1. I cubed is -I, and then I to the fourth is 1. And then these numbers start to repeat, and you start to get I to the fifth is equal to I, which is what I just showed you, and then I to the sixth is equal to -1, and then I to the seventh is equal to -I, and I to the eighth is equal to 1. So a lot of these numbers, they have a cyclic nature, meaning that they just repeat themselves. Okay, so let's take a look, and if we were to do something like this and say, okay, well, what if you had, say, I to the 23rd power? Okay, and how would you evaluate that? Well, what you would need to do is you would need to say, okay, well, I can rewrite this as I to the 20th plus 3. Okay, I can rewrite 23 as the sum of 20 and 3. So then when I have the sum of two exponents, that means that I have I to the 20th times I cubed. Well, I to the 20th can be rewritten as I to the fourth raised to the fifth power. And so then I to the fourth we know is just 1. So 1 to the fifth is just 1, and then we have I cubed. Well, I cubed we know is -I. So I to the 23rd, okay, essentially is equal to just -I when you evaluate it, okay? So let's take a look at some examples here for like I to the 37th power. Now, I'm going to do this. I'm going to rewrite this as I to the 30, crap. There's a number of ways of doing this. I'm just trying to think of the easiest way. I to the 37th, let's rewrite that as I to the 36th power plus 1, okay? And here's why, okay? If I rewrite this as I to the 36th power times I to the first, okay? I can rewrite I to the 36th power as I to the fourth raised to the 9th power, okay? The trick is to figure out some sort of multiple of 4 and kind of get it down to I to the fourth, because I know that I to the fourth is equal to 1, okay? And then times just I to the first. So then if I take I to the fourth, that's just 1 to the 9th power times I to the first. 1 to the 9th power is just going to be 1 times I to the first, and I to the first is just going to be I. So I to the 37th power is simply just equal to I, all right? Okay, now we've got kind of a trickier one. Let's do I to the 82nd power, and let me rewrite this as I to the 80th power plus 2, okay? And then let's rewrite this as I to the 80th times I squared, okay? And remember, the reason I'm doing this, guys, is because if I take I to the 80th and I squared, I would add my exponents, and 80 plus 2, and then 80 plus 2 just gives me 82, all right? So it's just one of those things where these are just, I'm just using rules of exponents right now. So I to the 80th, let's rewrite that as I to the fourth raised to the 20th power, okay? Now, when I raise a power to a power, I multiply. So 4 to the 20th power, or 4 times 20 is going to give me 80. Okay, and then times I squared. So then what I've got is I'm going to do I to the fourth I know is just 1. So 1 to the 20th power, all right, times I squared. So 1 to the 20th is just 1 times I squared, and I squared here is that's just I squared, which is going to give me a value of -1. Okay, because I squared is equal to -1. So if you had I to the 82nd power, that's equal to negative 1. All right, so on the last page we talked about imaginary numbers, but let's really kind of talk about what a complex number is. A complex number is something of the form of a plus bi, where a and b are real numbers and I is equal to the square root of negative 1. So what we have is, a is a real number, and so is b, okay? And so we use those numbers to help us come up with a value, and this is a whole number. When you have a plus bi, this is a quantity itself, okay? So what we want to do is we want to identify the parts of a complex number, okay? And so check each true statement about the number. So I've got 7 minus the square root of 3i. So the real numbers, okay, we know that 7 is a real number, okay? And so that's a true part, okay? And we know that, and it says here that square root of 3 is the imaginary part of the number. That's not true. I is the only part of the imaginary number, okay? Square root of 3 is a real number, okay? And it says 7 minus the square root of 3 is the coefficient of I. No, just only the square root of 3 is the coefficient of I, okay? And it says this number is the sum of real numbers and an imaginary number, and that is true, okay? The sum of a real number and an imaginary number, okay? And that's the idea, all right? All right, so let's go down here and let's talk about complex numbers in the plane. So we can actually graph these numbers. So if I were to sit here and say, all right, the x-axis is part of the real number system, okay? So x-axis is the real numbers, okay? And the imaginary numbers are like your y values, okay? So if I were to plot the numbers, say, like negative 1 and 2, okay? Here's negative 1, and here is positive 2, okay? Now, if I were to plot the imaginary numbers of, say, negative 2i and 3i, okay, negative 2i is going to be down here, okay, 2 away from 0, and then 3i is 3 away from 0, all right? So if we were to put these together and kind of, put them together, when you have the complex numbers, negative 1 minus 2i, okay, that's like taking the number, okay, and having the point negative 1, negative 2, okay, and that's kind of the idea. So I go over negative 1 here, and then I go down 2, okay, and so this is the number negative 1 minus 2i, okay. Now if I were to have the number, say, 2 plus 3i, that's like having the point 2, 3, okay, then I would go over 2, all right, and then up 3, and this number would be 2 plus 3i, okay, and that's the idea. So, let's come over here and let's, display and label complex numbers in the plane. And so point A would be, over 2, up 3. So that would be negative 2. So this would be the point negative 2 plus 3i, okay, knowing that this is a complex plane, okay. Point B would be negative 1, so negative 1, and then minus an I, okay. Point C over here would be the point 3, negative 4, so it'd be 3 minus 4i, okay, and then point D would be 4 up over 4 up 1, so that would just be the point 4 plus I, 4 plus 1i, okay. All right, so now let's talk about the absolute value of real and imaginary numbers. All right, so for an absolute value of a real and imaginary number, now remember, this is the real number line, and this is the imaginary number line, okay? So let's just say we wanted to do this. Let's say we wanted to calculate the absolute value of 2, okay? And what we do is we come over here and we'd say 2, this is the value of 2. What's the distance from 0? And that distance would be, say, 2, okay? What if we wanted to find the absolute value of, like, negative 3, okay? Then we come over here to negative 3, and we plot that point, and we say, okay, how far away is that from 0? Because absolute value is the distance from 0. And that's a length of 3, so this is a length of 3. So imaginary numbers kind of work the same way, okay? Let's say we wanted to find, say, the absolute value of 2i, okay? And 2i would be the point up here. and we're just talking about units. How far away is 2i from 0, the origin? Okay, and that's 2 units away. Okay, what if we wanted to find, say, the absolute value of negative 3i? Okay, then I would say go down to negative 3. What's the distance from that to the origin? And that's just going to give me a value of 3. So, the rule, kind of the rule of thumb, is that you take the absolute value of a number, it's just positive. Same thing with imaginary numbers, but you just drop the I and make the coefficient positive. So you drop the I here, make the negative 3 positive, and you just get a value of 3. Okay? Okay, so on the last example, on the last page, we talked about absolute value of those numbers, but those were numbers that were either on the imaginary line or on the imaginary number line or on the real number line. But what if they're somewhere out here in the plane, okay? Then what we have to do is we have to find the distance. Okay, the absolute value of any complex number, a plus bi, is the distance, okay, from that point, and let's just call this, the point, some point here, to the origin, okay? And that would be this distance, all right, is the absolute value, okay? And so, and since we know it's a distance, it will always be a positive number, okay? So what I want to do is I want to kind of, take a look at this for a second and say, okay, well, how do you find the distance between 2 points, okay? And so what we'd want to use is we want to use the distance formula, okay? And so when we do this, we have the distance formula of x2 minus x1 squared plus y2 minus y1 squared, where the origin is the x1, y1 point, and the point in the complex plane is just simply going to be the x2, x1 point, okay? So the reality is what we do is when we find the absolute value of a complex number, okay, the a plus bi, then we're really just taking the square root of a squared plus b squared, okay? So, if we were to sit here and say, okay, well, what's the, which of the following can be used to find the absolute value of 4 minus 7i? And so what we would do is we would simply just take, these numbers, okay, whichever one you've got, 4 squared, and then even if this number is negative, we still want to include that here, okay? Now, you could choose either this one or you could choose this one. Okay, they both give you the same thing. And the reason why is if you took that, you get the square root of 4, or 4 squared is 16, and then plus negative 7 squared is plus 49. Same thing would happen down here. Okay, you'd get 4 squared, which is 16, plus 7 squared, which is 49. And these two things are the same, and that's just what we're doing. Okay, so, all right, so then it says if we wanted to calculate the absolute value of 4 plus 7i, then, we're simply just going to do that, okay? And we would say the absolute value of 4 plus 7i is equal to the square root of 4 squared plus 7 squared, okay? Which would end up giving us the square root of 16 plus 49, which would end up giving, 49, not 14. So 16 plus 49 is going to be 65. So the absolute value, okay, of this number, the distance from this number to 0 is the value of the square root of 65, okay? And 65 is a perfect square. It's approximately like 8.1 or something like that. It's nothing crazy, but that's the, that's the number that we've got, okay? The last thing I want to do is this thing called dividing complex numbers, okay? And dividing complex numbers means that we are going to, we want to simplify this. Okay, we want to multiply, to simplify this and get I out of our denominator, we want to multiply the denominator by the complex conjugate. Okay, we're going to do that to the top and bottom. And the conjugate, remember, is just the opposite. Okay, it's going to be 7 minus 2i. And then the top part, we're going to do the same thing, 7 minus 2i. The reason why we do that is because this is going to allow us to, multiply this out, So I'm going to put parentheses around here and here. So if I were to simplify this, okay, I would distribute this I times 7 and then the I times 2I. So I would get 7I in my numerator minus 2I squared, okay? Now we'll simplify that here in a second because I squared is equal to negative 1. But down here, okay, we would do 7 times 7, which gives us 49. And then I would do the outside, so I would do minus 14I. And then here I would do plus 14I. And then 2I times negative 2I, let's do that here. That's going to give us the quantity, let's do that here. Let's do, I'm going to do plus 2I times negative 2I, okay? And so if I simplify this up top, I get 7I minus 2 times I squared. So that's going to be minus 2 times negative 1. And then this is all over 49. The 14I and negative 14I, these add to 0. Those go away, okay? But then down here what I'm going to do is I'm going to get 2 times negative 2, which gives me negative 4, and then times I, which is going to give me I squared. Okay, so from there, I'm going to do this. I'm going to do 7I and then plus 2. Okay, negative 2 times negative 1 is positive 2. And then I get 49 minus 4 times negative 1. Okay, so I'm going to do, and I'm going to reorder this. I'm going to flip these around to put the 2 out front. So I get 2 plus 7I all over 49, and this is going to be plus 4. So my final answer is going to be 2 plus 7I, okay, divided by 53. And that's my number in simplified form. The whole point of this is to get rid of the I in the denominator. Homeboy doesn't like that, neither do a bunch of mathematicians, and that is what it is. Okay, guys, I know this is a kind of a hard subject and kind of a weird concept for you to learn, but it is important for you to know how to operate with these numbers, and we'll go from there. So I hope you enjoyed this video, and I'll talk to you later. Peace out.